Okay, hello everyone. Today we're going to solve quadratic equations using the quadratic formula. This is the last method we are going to use to solve quadratic equations. And guys, frankly, it's probably the best method. The quadratic formula, it always works. All right, again, today's objective, to solve quadratic equations using the quadratic formula. Okay, this is the quadratic formula right here. Okay, we're going to work with it here today. It's a little cumbersome, but if you get used to it, it's not too bad. All right, the essential question, you guys need this for the homework check. What can the quadratic formula tell us about the solution to a quadratic equation? All right, it gives us some information about the nature of the solution. Now, we've looked at a number of methods in solving quadratic equations. All right, we graphed it. Again, if you have decimals available, it's an easy graph. It might be easy to graph it. All right, we can take square roots. That's if it has no x term, it's kind of easy to take a square root. If it's easy to factor, factor is a pretty easy way to solve a quadratic equation if it's easy to factor. But we can complete the square. Again, if it's an easy completing of the square, where the x squared term is 1, all right? You don't use complete the square too often, though, because why use complete the square when you can use the quadratic formula? All right, the quadratic formula, it always works on every quadratic. All right, remember the standard form of a quadratic formula. It looks like this. All right, this is in standard form. It has A, B, C. You need to be able to put it in standard form, again, of decreasing exponents. X squared, and then the x, and then no x. All right, because we can complete the square, this is a quadratic equation right here. And remember, completing the square, we can use it to solve any quadratic. So why don't we just take the standard form of a quadratic, complete the square, and solve it for x? All right, and when we do that, this is the formula we get. Now, real quick, we're just going to look at the proof. All right, the first thing you do is divide everything by a. All right, so that you have 1 in front of x squared. There's nothing in front of x squared. Then move the c over a to the other side, so now it's negative c over a on this side, and then you can complete the square. Remember, b over a, half of that is b over 2a. So you square that and add it to both sides. All right. On the right side, we go ahead and find a common denominator, and then we can put the numerators together under that common denominator. All right, on the left side here, we go ahead and write it as a perfect square. That's why we completed the square. We write it as a perfect square. Now we can take the square root of both sides. So we go ahead and do that. This is the plus side, and this is the minus side. All right, the b over 2a, we can move it then to the other side by subtracting b over 2a from both sides. All right, the bottom denominator here is 4a squared, so we can just take the square root of that because it's a perfect square. The denominator becomes 2a. And both the denominators are the same. So we can go ahead and put those two terms together. And that's how we get the quadratic formula, okay? Guys, the part of the quadratic formula that's underneath the radical sign, it's called the discriminant. That's a very important part of the quadratic formula. This b squared minus 4ac, that's called the discriminant. All right, it gives us information about the nature of the solution. All right, if the discriminant is greater than 0, then you have 2 real roots. All right, 2 solutions and they're real. If the discriminant is equal to 0, there's just 1 real root, okay? It's a perfect square. And if it's less than 0, if we're trying to take the square root of a negative number, it has no real roots, all right? They're complex solutions. We talked about that yesterday. Again, the quadratic formula, it looks like this right here. But we can take it and divide it into two terms by just taking this 2a and put it under the negative b, and the 2a and put it under the discriminant. So it looks like this. Guys, if you remember, x equals negative b over 2a, that is the vertex of the quadratic. All right, that's right down here, the vertex, where x is, the x-coordinate of the vertex is right here. The plus and minus side, this side right here, are kind of the two wings of the quadratic. You might think of it as swinging up here and hitting on this side, that's the plus side, and then start at the vertex and swinging up here and hitting in this side, that's the negative side. Okay, you can think of the quadratic formula like that. All right, guys, if you're given a quadratic to solve, you can plug the values of a, b, and c into the equation and get the answer. Okay, there's kind of two ways to do it. You can do it all at once, all right, or you can calculate the discriminant first, which is what I like to do a lot. Just calculate the discriminant first, and then the quad formula becomes a lot easier. It's just negative b plus or minus d, we'll call it a big D over 2a, okay? Either way you can do it. As an example, here's a quadratic. You have to get it in standard form, equal to 0. So the a is 8, the b is negative 2, and the c is negative 15. Here's the quad formula right here. So plug it in. Remember, it's negative b, so this is negative 2. Plus or minus, and then put in here, negative 2 squared. This always ends up being a positive number. Minus 4ac, and because there's two negatives here, we end up adding 480. The bottom is 2 times 8, 16. All right, 4 plus 480 is 484, and the square root of that is 22. All right, so it's 2 plus 22 and 2 minus 22 on top. So it's either 24 or negative 20 on top. We can simplify that, and there's our answer. All right, it's either 3 over 2 or negative 5 over 4. Okay, now we could have factored this one. All right, the fact that we ended up with rational answers means we could have factored it. We could use the slide method here. All right, let's look at example number 2, because this one you can't factor. I just want to show you that the quad formula, look back at example 1, you can use it for any quadratic. Even one you can factor. You can always just use it. All right, example 2. Again, we get it in the standard form, A, B, C. Here the A is 1, B is negative 4, C is negative 3. I plug it into the equation here. All right, I get a plus and a minus, and this time underneath the radical, it's the square root of 28. That's 4 times 7. And the square root of 4 is 2. If you remember, we did that before. So it's 2 times the square root of 7. So you have to leave that square root of 7 like that. So 4 divided by 2 is 2. And 2 divided by 2 is 1. So our answer is 2 plus the square root of 7 or 2 minus the square root of 7. And you can see here 2 is the x-coordinate of the vertex. This is a graph of this quadratic. 2 is the x-coordinate of the vertex. If I added the square root of 7, it shoots up here and hits a little, 4, a little less than 5. If I start at 2 and I subtract the square root of 7, it comes up here and I'm at negative, little less than 1, less than negative 1. Or I'm sorry, greater than negative 1, but less than 0. All right. Guys, that's it. Please complete the homework check. And these are the questions that are on the homework check along with the essential question. All right, that's it. Thank you.